we do, we are many now, but there are there are a few new faces.
There's a Scala quiz for the new faces.
Sam is Tom. So Tom is from the US.
Yeah.
What's your relationship with Scala, or are you just curious about the language? You use it, or what?
I do visualization research, and I have a visualization tool written in Scala.
Okay. Cool. And Helmut?
Yeah, from Vienna. We're mostly a Java programmer and interested in Scala. Using it.
Cool. And that's it for today.
Over there.
My name is Stefan, and I work near with Chris. So I use Scala for 3 months now.
So you're an expert, right?
So
Yeah, sure.
And today's drinks.
We are sponsored by Force. So after a limit of 150 euros, you can take drinks out of this nice which is
Per person, right?
Thanks a lot. Okay, so Radim, what did I have to play? It's already recording. You're recording it. Okay.
Das ist nicht kompilierbar.
Okay, so this is the agenda. This is a kind of introductory talk, because I thought we had many talks which were really advanced, so this talk might not be so useful for you guys who are daily in contact with Scala, but for the newcomers maybe. So I'll go through the object-oriented features. I'll show an example about pattern matching. I'll talk a little about immutability and functional programming in general. I won't talk about actors because we had a wonderful talk last time, I guess. It was a nice comparison between actors and J2E. So those of you who are interested, just download these slides from last time. And the last two are features and implicits. I have about 30 slides, so this should be a warm-up for the presentation about play, which is going to be presented after me. Also, I'll try to always compare Scala with Java, so don't be embarrassed if I start with Java first and then go the way toward the Scala. So first of all, how would you do data transfer objects in Scala? This is pretty much easy. We all have written something like that. So you have a first name property. On a class you have a getter setter. Obviously Java do not have a property, so you have to generate them by IDE, or if you do not have an IDE, you have to write them by hand. So, and then you're in debugger, and you see that just this person class doesn't show you any info, it just shows this default implementation from toString, which is like, I don't know, position of address or something like that. So you have to basically write something like that, where you have to explicitly say first name, last name, and just concatenate it into string. I don't use in string buffer here, so if you're already pattern. Okay, so this is the second method. The third method you have to write is equals, right? So have to generate it. So this is also something that really annoys me about Java, because you have to do it every time. If, for example, your class has to be in set, which uses equals. Okay, so right, that's it. As usual, hash code. But in Scala, and there's also, if you're very nice to a developer or you are API developer, you just provide some kind of builder class, so you can chain the method calls. So you do not have a setter which returns void, but you have a builder which you can build, in several method calls. Scala has something what's called case classes, and this is basically data transfer objects done right, because you have all these things I've listed for free. So first of all, these classes are immutable, as usual in Scala. You have toString equals and hash code implementation, so you don't have to write them. And you have some kind of very nice features, like you have something what can be achieved in the builder I've showed. So you have a copy constructor where you can only alter, for instance, last name. So this is a very nice thing. And also, case classes are capable of what's being called pattern matching. I'll show you later in the slides. So basically, all you have to do, you have to say case class, and you list the arguments into the constructor. So you can also, as you understand, provide some basic implementations for the properties. So here we have build case. If you call person without any arguments. Also, you do not need to provide new keyword, but that's only in case of case classes. If you have a regular class, you have to use new. Laziness in Java. This is basically how it's going to be achieved in Java. So you have to initialize some property which is now every time. So first time it's going to be called. So I think every one of us has written something like that. What?
It's not thread safe.
Yeah.
What is not thread safe?
This initialization in Java is not thread safe.
Yeah, it's the same in. Just this is like you can use it. That's the same with the singleton pattern. But there are ways how to achieve it. So within a static class, or using, I don't know, enums, or
You need to synchronize it by twice.
or with this.
Memory model.
Yeah, it's copy paste from Wikipedia.
Stack Overflow.
So in Scala, everything you have to do is just lazy well. It's simply amazing. Imports. So we have imports also in Java, but in Scala, you can have them anywhere, and not only at all of the classes in Java. So, for instance, as I've showed you here, you can introduce what's called alias. So basically, what says is your map is now mobile numbers, and you can reference it later, so you know the name is more exclusive in terms what's in the map. So actually this is my real number, so please don't call it if you're drunk or something like that. 55112. This is the way how singletons are being made in Java. So everyone who was, yeah, that's the same. But this is the last time I visit, so. So basically, every interview or you're asked for write something like that. I don't know why. Maybe these managers think that if you're capable of writing singleton, then you're the ultimate senior Java developer. So in Scala, we have something called objects. So in this example, we have a class which is called companion objects. Has two IDE and descriptions, and we define what's called companion objects. Object, which basically has 3 types or 4 types of informations. Either you have factory methods, what's the 0 function. So every time you call 0, you get a new object with ID 0 and description. Also, you can define an apply method, which give you a shortcut for in the terms that you do not have to use new keyword. That's the second example, the one method.
So what does it do? Sorry.
So if you define apply method in the object, in the companion object, which has the same name as the class, you can then call the class like with a shortcut, without a new keyword and with the constructor parameters in it. And the object that's called companion object. So the third one, you have some constants in it. So for example, error messages. And I guess you can also have implicit conversions here, which I'll talk about later. So this is a very nice way how to, extract things which are not related to the domain, to the class, somewhere outside of it. So, any questions so far? So in Java and pattern matching, we all know that. We're gonna have them in Java 7, which is scheduled to be 2014, I guess. So if you're lucky, we get them next year. But I don't believe Oracle in this, so maybe it's time to switch to Scala. So in Scala we have built-in support for them, so you can pretty much match based on strings. So you can either have or. So you can match also based on number of elements in sequence. That's the third case. The fourth case. Okay, so if you have 2 elements, this case match. So if you have more than 2 elements, the second one will be matched. You can also match based on a type. So That's this case also with the guard. So something what I think Carol introduced like 20 years ago when I started with programming. Or you can have a default branch either with underscore or you can write something like that if you need a variable in the later in the statement. So this is a very, I would say, easy, and the readability of this is very natural. So this is something what sold me for Scala, I guess. Very easy way just to decide whatever. In Java you have no way. You have a switch statement that, as is said, doesn't know how to switch on strings. You have only primitive types, I guess, and enums. So this is like unuseful. This is maybe for advanced users. You can use switch annotation, which means that the whole match cases are translated into lookup table. So, but it only works with primitive types. So, in the that I guess that wouldn't be possible to translate it into the lookup table.
Yeah, translate to lookup table or normal switch.
I don't know. It's like something amazingly fast. So in this case, I guess the guard, would cause problem because you cannot have a lookup table with. Yeah, you could, but I don't think that the compiler is so clever just to evaluate the guard. Okay, so let's go through the some of the concepts in functional programming. Immutability. So in Java, as a good example, string and big decimal are classes that are immutable. So basically, you have no way how to change them internally. A new instance is always returned. But every other class is, I guess, some kind of mutable, the most important one.
So just because you mentioned the sort of interview kind of case, one typical question as well is like, is string actually an immutable type? Which it sort of by definition isn't, because the hash code is sort of calculated on demand. I mean, it sort of doesn't have any effect on the application, but by definition, string is not an immutable type.
In Java or in Scala?
In Java.
Uh-huh.
From my point of view, string is immutable.
Yeah,
also Joshua Block writes that it's immutable class.
It's immutable.
You can't change it.
Yeah, you can't change it so that it has effects outside, but the hash code internally changes.
Yeah, but
Exactly.
Yeah, you don't.
What do you mean by hash code changes? If you call hash code 5 times, it gives the same result.
The hash code is
Calculated.
lazily.
Yeah,
Yeah, but
it depends on the definition what's in the
but if you call it 5 times, it will return the same value.
yeah. Well,
Nothing is immutable. The compiler or the runtime can modify whatever you want.
Yeah, but it is immutable.
That's not the thing. I mean, that's true, but that's not part of the definition. It's just like when you initialize, the definition of immutable is as soon as you initialize the whole thing, it can't change anymore.
No.
But the string can change because the hash code sort of goes from uninitialized to initialized later. But that's just sort of
Yeah, but it's derived property, so your base property are unchanged, so you are immutable. everything what's derived property is always calculated from the base properties. And when base properties are not changed, everything what's derived property can change because it's calculated later.
Is that the definition of an immutable object?
Yeah.
So all the methods of an immutable object have to return.
And basically, hash code is a method and not a field.
But it has the field hash code internally.
Yeah, but it's an internal representation.
Yeah.
It doesn't matter. From the interface, it's a method.
Yeah, but yeah, it's just a matter of definition. But
And maybe this is a little bit misleading. This doesn't mean that val ensures that this object is immutable, that this reference cannot change. It's like constant.
So what in Java or what?
Also in Scala, when you, for example, have val immutable, but you have a mutable type, that means well,
you can have a mutable map. That's
for example,
perfect.
then that means that only this reference, the variable name is immutable, but the type can be mutable internally.
So you have only. I think that's the same with final variables in Java.
Yeah.
Yeah. So
Same thing.
So this is a example with primitive values. As you say, so mutable are marked with var keyword, whereas immutables are with val, and you cannot change immutable in this case. So if you set immutable to 4, that wouldn't compile it. So this is maybe a good example how to show what we discussed. So in both cases you have a val, which is which says that the reference is immutable. But in the first place, if you write 1, 2, 3 reverse, and then you reference in the second statement, reverse it again. So as expected, you have a 3 to 1, 1 to 3. But in the second case, you have a string buffer which has also reverse method, but this reverse method changes the internals of the string buffer. So after you reverse it again, you have the same object twice. So maybe this is a good way how to understand the difference between immutables and mutables. Any questions? High order functions. This is a basic, and we've already done that. So you have a map function which takes. Okay, so maybe what's higher order function? It's basically you have two kinds of higher order functions. Either one which takes a function as a parameter, or one that returns function. So in this case, this is the map function which takes another function. This is, I think, not very clear from this point, because what I'm actually doing in this index sequence, I'm calling the function from underscore to underscore plus the h. So this is a function, and you call to uppercase in the next line, and as you can see, this prints with the lowercase, because this is I haven't assigned the result of this command into any variable. So if I did it, I would have for ph with in uppercase. also maybe a good example of immutability. So in this case, this command hasn't altered the state of the S. Something parallel connections. In Scala, you have a very nice way how to say that the processing of function over the whole collections should be performed, in parallel. So if you find high enough number, as I did in the morning, so you finally see that the number of cores you have on your machine you are more performant with your parallel connection than with your sequential approach. This is just maybe nice to have, but I haven't used it yet. So,
The thing is, when you have immutable, when you write everything immutably, you can then just import the parallel collections instead of the normal collections library, and boom, everything is multicolor. You don't have to change anything in your code that you wrote. So if you write purely immutable code, then you can really make use of this parallel nature of the compiler, of the library.
yeah, but you have to say explicitly. So
No, what you can say is, instead of saying, or you use a normal library sequence list map whatever, and then in the top of your file you say import scala.collections.parallel.
Oh, well,
And then
you change the namespace, so
So you change the namespace, and then all the collections that you use are suddenly the parallel ones, and without having to do anything, your code suddenly runs on all the cores without an additional cost. And
yeah.
that's the main argument that Odersky brings up when he sells Scala. He says, boom, we've got it for free.
But before checking, you have to use these game collections. There is a special interface for the parallel collections. They will start this game. And if you have to have some functions, some utility functions, then you have to use this special kind of.
If you want to implement your own ones, you mean? If you want to implement your own collections?
No, Wolfgang says that you have to use some special interfaces
Yes.
and not
That's what I
normal.
when I use them.
No. It's just, the only thing is the whole collection library is built on these builder traits and patterns that are called gen traversable ones, etc., etc.
Yes, that's what I meant.
So if you want to build your own maps or something, and if you want to make use of this parallel stuff and all the fluffy integration and the whole Scala, you should use these traits.
so if you want to build your own custom collection that extends map or so you have to extend this gen.
Yeah.
Okay.
But when there's then a special implementation, for example, for list in the car.
Yes.
So if I change the import statement and all my method signatures would change to the parallel collections.
Exactly.
And the callers would then have to.
That's also what I learned. You have to define all these game lists from the beginning.
Yeah, I mean you have to see where you put your import statement. Don't put it on the top of your class or in your trait or in your external interface.
I mean, just in a method.
Just in implementation or inside of the method.
Yeah.
But it's really powerful. I mean, I tried it a few times and you just suddenly, for free, your code becomes multi-core and runs on 16 cores instead of just one. And you didn't have to think about synchronized statements or anything.
Yeah. But just to say, I started this morning with 1 to 10, and I had to add, 6 numbers just to show you that the parallel connection is better. So maybe it's a crucial point is maybe the map. So in this case, it's not so much computation.
So So what does the second number say? I can't read it.
Well, it's 3,700 something, so something better performance than
Yeah,
what's
but it
on
starts
Scala.
to measure it with startup time, and if you start using power collections, it has to start maybe the thread pool, the fork join pool, and you have to measure it multiple times, in fact, and normally you have a more complex function than this one.
Yeah, that's what I said. So maybe not just increment of the number, but some. So move on. Carrying is basically if you have a function which takes many parameters and you carry it so that it takes only one parameter and can be applied sequentially. So in this case, you have a product function which takes I and j, and you split it into two. So then you can have a times 2 function which is partially applied with the I fixed on 2, and underscore means the rest of the function, in this case j. So you can have a times 2 function. It's
Another question.
Yep.
Is carry only possible with multiple parameter lists, or can I do carrying also with, let's say, the last parameter in my function of active parameters? Or does anybody know?
Good question.
I think it's possible.
You don't just have to take
Right.
the compiler won't find the type correct. But we get some problems that the compiler does not find the right type correct.
So what?
So what do we want to do?
Let's suppose I have a function that takes x and y, 2 parameters.
Yeah.
And I want to do a new function where the x is fixed and the y is still free.
To write this order.
Yeah, that's example.
But only
Comma.
One parameter. You have an argument.
This
Two
interverse,
arguments.
But you get problems with it works better with this.
I would be disappointed if it didn't work.
Okay, so with one part, I don't think it works because of the parameter.
But he's checking.
I don't think.
Did you get back that partially applied function?
What?
Did you get back the partial? If you put in an underscore for your arguments, don't you get back the partial function?
Times 2, you mean? Or
No, like product if you had this one. That's not product. No, it doesn't. I forget to put an argument. It says put it in an underscore if you want to get partially applied function.
Check it out. Okay, so this is partial functions are it gets
It goes, but you have to define the type. That's all.
for the argument.
For the argument, what you want to get.
So partial functions are, functions that are partially defined on arguments. So in this case, this function is only defined for even numbers, and you can use the collect method just to select only those which are defined. So this is you can later use it for there are other methods in collections, for example get or else, so you can chain these partial functions, but I think partial functions are used in actors
Everywhere. Also.
yeah, this also
Also, for example, catch statements, try catch block. All these cases are partial functions.
Yeah,
everything
or
is part of
cases without match, I guess, also.
Also cases in math.
Or actors in receive method. So
Actions in play framework.
yeah. So
Everything is part of
so actors, we've covered them last time, so let's skip them. This is a very, I would say, very simple example of futures. So futures are something what holds, which is a holder for a result in future. Can either succeed or have a failure or exception in it. So in this case, you have a future which sleeps for 1 second and then produces 16 A's. And you have a method call on success, which enters the number of A's into total A's variable. So I don't know, maybe you don't see it, but if you, it's an object which extends app. So if you run it, then the first it brings 0, and if you wait another 1 second, it brings 16. So it is really, this statement is called when the future is being computed.
What's the equivalent in Java? I think there is also
Yeah, but I
there are
don't
also
have,
futures in Java, or what's the name?
yeah, there is, but these are I don't think they are asynchronous. Are they?
But they are asynchronous. They are executed in a swap pool.
Yeah.
The concept is the same, but the futures in Java just have a get method. That means in some point in
Can you turn
order,
around?
you have to ask for a result and you block.
Yeah.
Block your current
Blocking.
thread.
Yeah.
And here futures they are called on events. So on success on something, you also have this get methods and so well, when you want to block you can block. But these futures are also composable. So they have all the functors to compose future to future and wait on them.
Yeah, you can use them in for
That's the main
comprehensions.
difference.
So you can have
For
a future and another future which waits till the first one is computed.
So you mean that in Java we would have to have another code outside here and then call is
Yeah,
ready? Or
in Java,
I think it's blocking.
You will have this text, then you have your code, and in the end, somewhere when you need the value from this text,
yeah,
from this computation, you will have text get. And this call
Will
of the
block.
method is blocking. So
Okay.
somewhere in your code you have to block. And here it's even driven. Look, you have a future, and then when future is complete, future calls your on success method. So
okay.
Yeah. You also have a on failure method, or you have also on complete if you want to call
it's a
them.
different concept. But yeah, in Scala you have also this get method for blocking, but it's useless. Basically.
Yeah. So implicit conversions, I think this is really evil if you want to write them. So implicit conversion is from one type into, it's basically a function from one type to another. In Java you have, for instance, string value for passing integers from strings. So those are functions from integer to string. So maybe, but implicit conversions, you see them everywhere, but I think you're not aware of them. This case, for example, in the example, so you have 1 to 4, and certainly 1 is integer, and 4 is also integer, and there's a function 2, and this function isn't defined integer. So this function is defined in an object what's called rich integer, and so what it does, this function requests implicit conversions from integer to this rich integer, and also for the parameter. And once you get it, those are just normal method calls on rich integer, so you can use them as you wish. I think this is the last slide. You have also something that's called implicit parameters. So, for instance, if you need a maximum and you do not stick any special ordering, so the implicit one is chosen, or so this is the method call from standard collection library, or you can do it on object level. So you can have a query which does something, but if you do not send a timeout, the default one is being chosen, and this is being claimed in the companion object. So you just define implicit value for timeout is 10, and if this query is called somewhere here, so it will produce the 10s from the companion object. So again, this is like the apply method, so you can save the timeout, the new keyword here. And I think that's it. So if you have any questions, what's the time? Yeah.
Good, yeah.
I wanted to talk about type and category theory, but
With this heat.
I thought that there's another presentation behind, so let's save it maybe for next time or never. So,
Okay. Do we take a 10-minute break now?
yeah.
10-15 minute break? Just stop.